I suggest having a place that you can take notes that has like 4 categories. That's why I gave you this paper. Now, if you want to fold your paper so it has these 4 categories, well, you have to fold it in half. It doesn't matter which way, and then fold it in half the other way. So you basically want to fold it in half twice, but 2 different directions. By the way, if you don't want to take notes like this, use your notebook. It works too. But I'm going to give the notes like in 4 different categories, and students tend to like this. Now, if you want to get the little flaps and tabs, if you want to get these little spaces, first of all, I wouldn't make them too big. But if you want to get the extra spaces, there's 2 triangles that you can fold, 2 corners. One of the corners is open. It's like all 4 sides are open. Fold down a little triangle. Again, I wouldn't make it too big. And then the opposite corner is totally closed. Same thing if you fold a little triangle. If you accidentally folded the wrong corners, you're just going to get some extra lines on your paper. It's not too big of a deal. If it was me, I probably would write solving trig equations in the middle. That middle space is usually where you put the title. So if you want to write solving trig equations or something like that in the middle, okay, now in each of the 4 blocks, we'll do 2 examples, except for the last block. So maybe plan yourself to have enough space for 2 examples in each block. And I'll probably give you some like little informational pieces that you might add to those spaces, okay, like some text or some words. And lastly, having a calculator handy is actually it's honestly just as much a part of this as anything else. So having a calculator, you'll find out it usually is your last step. Okay, it doesn't have to be graphing. It doesn't have to be Desmos. Honestly, just a scientific calculator like we've used some other times this year. Something that has sine and cosine on it. All right, now this probably will take the whole period. I just kind of to plan accordingly, but I don't want to like race through this because I want to give you time to think. I want to give you time to use your calculator and obviously to understand each of these 4 sections. We're going to talk about this for a few days though. So if there's something today where you're like, I don't know if I quite got that, there's a good chance we'll talk about it some more tomorrow and maybe the next day. Okay, but we're going to start with what I like to call just basic inverse operations. Basic inverse operations would be the kinds of equations that you might have been able to solve before you came to class, but it's still where we want to start. I'd probably write that in this first little flap or something like that, something about inverse operations. We're going to do 2 examples, so give yourself some space, and I'm going to give you some text. In fact, this is the algebra chapter, but I want you to understand that I'm kind of assuming that you're thinking like an algebra student. Okay, so there's going to be a few tidbits, but that's always true. You want to think algebra. So 2 cosine squared of x minus 1 equals 0. 2 cosine squared of x minus 1 equals 0. You'll realize that this is a pretty basic equation. We can just jump right in here. We can think algebra. We're solving for x. And just like you've done many times with algebra teachers, you do things like inverse operations. You isolate x, and something like adding 1 to both sides is definitely a yes. I don't care if you show it or not. I know it's kind of basic, but you do get 2 cosine squared now equaling the number 1. And you continue to do things that would solve for x, like dividing by 2, another pretty basic inverse operation. So we divide both sides by 2. Again, that is completely legal. And now we have cosine squared equaling a half. Now we do get to a little juncture here where, whoops, it's cosine squared of x equals a half. That x is important because that's what we're solving for. Now we do get to a pretty important juncture that we have to think about getting rid of this exponent. It's kind of like next on the list. Now you've done this in algebra before. We even did it this year, but remember that if you take the square root of both sides, you can get rid of a exponent of 2. So that's another yes. Here's something worth repeating. And this, you've heard this before from other teachers, but it's worth repeating. Whenever you take a square root, you always get a plus or minus. So actually, as soon as I took the square root of both sides, I got a plus or minus the square root of 1/2. Okay, that's because a positive or a negative is able to satisfy this equation. I don't know if you want to remind yourself of that as a little tidbit. It's pretty important though, because again, I now have 2 numbers. I have a positive and a negative. All right, now it's kind of a little weird. I've got this square root of 1/2. Unfortunately, that's not like a clean number. It's all right though, we'll do it on our calculator. But I actually have 2. I have a positive and a negative square root of 1/2 that I will work out on my calculator once I think about this last step. Okay, now this last step's important because you do it like every time for the rest of this lesson. And that is that you need to get rid of cosine. Now, don't do something silly like divide by cosine. That would be silly because we're not multiplying by cosine. Okay, so that's never going to work. But I do need to do like the inverse of cosine. Literally, I need to do inverse cosine of both sides. Take a look how I did that. I'm writing inverse cosine on both sides. That's how you cancel cosine. That's going to give you x. And that ends up being something that we work out on the calculator. We haven't done this for a while, but early in the year when we were solving triangles, you guys would have many times you would have hit the inverse cosine button. Just make sure that you're still doing the right thing, especially with this square root. So it's the inverse cosine of the square root of 1/2. Now it comes out to be an angle, comes out to be 45. It will always be an angle. But for this problem, I end up with 2 angles because I'm also going to do the inverse of negative square root of 1/2. Careful where you put the negative. Okay, careful. The negative is on the outside of the square root. And again, you get an angle. You actually get a completely different angle, 135. What do you think here? I'll share with you this type of problem. It will be sort of like inside of every problem we do the rest of this lesson. So you always will do the inverse. Honestly, you'll always think algebra. You're not always going to take a square root of both sides, but still the main steps will be the same. Let's do another one in this category. I'm going to put it underneath. You put it however it kind of makes sense for you. It's going to be the cosecant of 2x minus 3 equaling 0. The cosecant of 2x minus 3 equaling 0. Now, maybe that cosecant kind of gets your attention. We'll deal with it. It is actually requires a little bit of a fancy move, but let me talk about grouping symbols for a moment. The way the problem's written on the board, you would assume you would know that the grouping symbols are only around the 2x. Now, they weren't written there, but again, that's what it would imply. You say, well, what else could it be? Well, it is not this. It does not imply that. If it was, I would have put the grouping symbols there. So 2x minus 3, that entire quantity is a lot different than just 2x because of your algebra. Okay, my first step here would be to deal with the minus 3. My first step would be to add 3 to both sides. But that's a pretty common idea, again, doing inverse operations. Okay, so we get cosecant of 2x equals 3. Cosecant of 2x equals 3. We have a little problem. If you're saying, yeah, this cosecant, how do I do that on my calculator? Well, you don't, okay, because there's no cosecant button. But what you're going to do is you're going to interpret it as a sine. Now watch carefully, because this is something that we've been trying to teach you throughout this chapter. If you interpret this as a sine, you're thinking about its reciprocal. You say, I can just change it to sine. Well, I have to do the reciprocal of both sides. Now, to show you the reciprocal of this side would just be 1 over 3. But if you're like, well, how'd you do that? I just did the reciprocal of 3. But I did that because I'm also going to have to do the reciprocal of this side. Now, the reciprocal of cosecant, that's sine. And this is a little fancy, but what I've done is the reciprocal of both sides, which is totally legal. It's just that when I do the reciprocal of cosecant, I get a more familiar function. I get sine. Don't forget to do the reciprocal of 3. I just get 1/3. Now, inverse time. Inverse time. You always do the inverse to get rid of a trig function. So we do the inverse of 1/3. Okay, now whether you show that on your paper or just do it on your calculator is fine, but you have to do the inverse of 1/3. You might want to check it out. It's not necessarily like a nice clean number. It comes out to 19 with decimals. That's all right. It's 19 degrees with decimals. And you have to divide it by 2. You have to divide it by 2 since it's 2x. So just take that number on your calculator and also divide it by 2, and you'll have your final x, which is more like 9.74 degrees. 9.74. What do you guys think? Again, every problem is going to have kind of this idea embedded in it. So we want to make sure you're okay before we move on.
Will we always get a degree?
You'll always get a degree. And I like to say it'll look like a degree. It'll look like an angle. And that's a good point. Actually, when you think about it, that's what x has to be, because we always do the trig function of x. We always do a trig function of an angle, of a degree. All right, now, that's that category, but it's going to be in every category. But let's now get to some kind of special categories. Oh, I forgot a little tidbit here. Whatever it takes for you to think about what I did here with the reciprocal. Okay, I more just want you to realize that sometimes you have to carefully do a reciprocal. The word carefully means a lot of things. It means that you have to do it to both sides. It means that you have to use a reciprocal function, where cosecant turned into sine, for example. You only ever have to do that if you have one of the uncommon functions. Okay, you only have to do that if you have one of the three reciprocal functions. Okay, I'm sure that's not the last time that will pop up, and we'll keep working that out. Factoring. If it was me, I would put that on the next tab right here, maybe this space in your notes, factoring. I'll tell you, you guys have shown that you're fine with factoring. It doesn't have to be a hard thing. But when you use factoring to solve an equation, well, we have some things that we have to sort of take into account. Tangent squared plus tangent equals 0. Tangent squared plus tangent equals 0. My hope is that with all the work you guys have done in the last couple weeks, that you would look at that already and say, yeah, that's a factoring problem. I'm going to still put this down, but you've heard me say this a few times. Okay, you're always going to factor when you have a repeated function, right? You always factor when you have a repeated function. It doesn't hurt to see it again. Okay, so in this equation, we have a tangent, and then we have another tangent. Obviously, tangent is repeating. So we do the familiar take out the repeated function, take out the GCF, factor out a tangent. Well, you don't need me to tell you, do you? What do you get? What do you get when you take tangent off of tangent squared? It's like you're dividing it off. So now you're down to tangent. And what happens when you take tangent off of tangent? It's like you're dividing it. So you're down to 1. You're down to 1. Now, this is an equation. So you kind of have to remember in algebra what you did next to help remind you. It's all about 0. It's all about 0. Okay? When the equation's equal to 0, when you're factoring, then, and I like to kind of think of this as like two separate equations. Then each one of these factors itself is equal to 0. It's kind of like saying what's going to make tangent equal 0. It's kind of like saying what's going to make tangent plus 1 equal 0. Okay, now this is like the factoring strategy where you make each factor equal 0. And now you've got two problems to solve, but they're usually pretty easy because, again, they involve 0. Okay, now I've seen this in the past. Of course, I don't want it, hopefully, in the future. And that is that sometimes kids aren't sure how to finish this. It's the inverse. I'm telling you, you always do an inverse, and it's probably just going to be on your calculator, which is fine. But you can't just like stop here. You have to do the inverse of 0. And then on this problem over here, you have to be careful that you first subtract 1 so that you can do the inverse of -1. Same thing, be careful you're going to do the inverse, but it's going to be of -1. How you doing? Are you sure you're okay with, we got 2 answers, we have 2 inverses. Okay, the inverse of 0 and then the inverse of -1. You have to make sure you move the 1 over to the other side so it's negative. And once again, you get some angles. It's 0 degrees, and of course -45 kind of looks like an angle. Factoring. Okay, now we're going to have another example, but we'll save it for tomorrow. So let's move on to the next category. But again, keep some space there. Now, this is kind of what we've been ready for. This is what we've been getting ready for, because the next category is really the purpose of this chapter. Identities. It's everything I've been trying to train you to be able to do. Identities. And you're ready. Okay, again, from my viewpoint, you're ready. From my interactions with you guys. Sine of x equals the tangent of x. Now, I don't know if you expected some big giant equation. That's not necessarily what has to happen. Actually, what happens is what has not happened in the other 2 categories. Just take a little walk back with me for a second here. There's something about these 2 categories compared to now this third one that makes it stand out. Do you see? There's something that's true about these categories, both of them, but is different over here. Well, that definitely is true. I noticed I wrote them that way. So I can't fault you for saying that, because it definitely is true. It's not what's significant. Just so you know, this one could have equaled 1. I could have made it equal 1 if I wanted to. This one could have equaled 3. I just said 0.
You just need an identity.
2 different functions. That's exactly right. Okay. 1 function, cosine. 1 function, cosecant. 1 function, tangent, even though it repeats. 2 functions. Now, when you have 2 functions, okay, now it's time to use the identities. Now listen, I don't want you just to do something because the teacher does it. I want you to be thinking why we're doing this. And boy, this is a big one. 2 functions. Now, if you have 2 functions, and it's different, right? I should be saying 2 different functions. But if you have 2 different functions, it's all about trying to get them to be 1 function. Okay? It's all about trying to get them to change, to convert to 1 function. You know, kind of like what you tried to do with a lot of the problems the last week or so. You've been trying to simplify them. You've been trying to get things to cancel. You've been trying to use identities. And that's exactly what we're ready to do here with this sine equals tangent. Are you kind of feeling like changing tangent? Okay, do you feel like we've changed it many times? Can you change tangent so that it looks a little bit more like the function I have over here? Okay, can you change tangent to be sine over cosine? Well, sure. We just did. It's called the quotient identity. Now, if you're like, well, why did you do that? Well, probably these signs are going to interact, just like they often do. And when I say interact, what I really hope is that they cancel. Because if they cancel, then maybe I'll end up with just one function. Now, multiplying cosine to the other side, okay, it's probably a good idea because I don't want to be staring at a fraction much longer. So let's multiply cosine to both sides. It's definitely legal algebra. Why are we doing that? Well, we're honestly doing that so we can get ready to do something to these signs. And this is really the key step. We want to do something with those signs. And that something is we want to cancel them. Now you cancel the signs by division. Once again, good algebra, dividing everything by sign. Yes, you're allowed to do that. But look what happens. You end up with 1. Honestly, you end up with no more signs, but you end up with the number 1. And you have one trig function. Okay, and you should be thinking about finishing on your calculator. I don't really care if you show it or not. I'm showing it just so you know what I'm doing on my calculator, but if you're just popping that in, do the inverse of 1. Great, that's what's expected. Just pop it in and do the inverse of 1. Okay, you're going to end up with 0. Listen, this category is pretty big. That doesn't mean we're going to do like 10 examples, but it means that the 2 examples we're going to do might not cover everything. So we're going to keep talking about this. This is honestly really what this chapter is about, to be able to solve an equation that needs identities. So here's another one. Secant plus tangent equals 0. Secant plus tangent. Again, sometimes it's that first step, just like we've talked about many times, and maybe I need to give you a little guidance on the first step so that next time you kind of think the same way. I'm going to suggest that, like we've done many times, that we change everything to sines and cosines. Now, I should have asked you, how do you change secant to be sines and cosines? So I hope you would have said 1 over cosine. That's the reciprocal. Tangent, I'm going to change the same way as I did before. I'm going to change it to be sine over cosine. So I want you to notice that we're changing everything to be sines and cosines. Pretty popular move. What do you see? What do you see? Don't look in your book. It's not in your book. It's more of an algebra thing. Common denominators. Hey, sometimes we have to like make a common denominator. We are given a common denominator, like it's automatic. So use it. That means add the fractions. You know, add 1 plus sine. Okay, so we're trying to get rid of a trig function. We're trying to eliminate a trig function. I want you to take full advantage of that 0. Because what that 0 is going to do is it's going to zap this cosine, right? When I multiply cosine to the other side. I'm trying to show you guys some of the moves that we can make. That's a good move. First of all, you're allowed to multiply both sides. And second of all, it zaps that cosine to disappear. So if 1 plus sine equals 0, and as I've said a couple times, when you get to the step where you are ready to use your calculator, use it. Please make sure, though, that you're doing the inverse of -1. I didn't show it, but you subtract 1, and then you do the inverse of -1. It's a trickier category. It requires using identities. And now I'm going to throw one more wild card at you. It also requires checking your work. Okay, this is kind of one of those things where we should probably do this more, but if I don't talk to you about it, then I'm not telling you the full truth. What's going on? Well, negative 90, we did a nice job finding it, but it turns out that it actually doesn't check in the original equation. Okay, say what? Well, if you plug negative 90 back into the original equation, I'm talking about secant plus tangent. What that means is I'm going to try to do the secant of negative 90. Now, that in itself is a little fancy because there's no secant button. So I have to do 1 over cosine to try to do the secant of negative 90. It turns out that when you try to do that, you get a math no-no. You get a 0 in the denominator. How about if I try to do the tangent of negative 90? Actually get another math no-no. I get a 0 in the denominator. What's going on here? Well, what's going on is that negative 90 turns out to not actually check. It's not actually the solution. You can cross it off. You can put undefined beside it. And let's talk about why it suddenly popped up in this problem. Okay. Again, if I don't tell you this, I'm sort of withholding some of the truth. I don't want you to worry, though, that like all of a sudden everything's not going to work. But I do want you to know that if your equation starts with a fraction, you need to be sensitive to the possibility of a bad answer. Now, what do I mean starts as a fraction? Tangent is a fraction. It's sine over cosine. Secant's a fraction. It's 1 over cosine. Actually, here we had another fraction. So should we have checked 0? We should have. Okay, we should have, but it was going to work. Here's some fractions again. Should we have checked these answers? We should have. Okay, now, not every problem starts as a fraction. Here's one that didn't. But it is true that there's a lot of fractions in trigonometry because a lot of them are defined like that. Okay, there will be some times where this happens. You just need to be aware. Okay, I'll keep kind of reminding you, but let's take a look at the last category. I want to sort of show you all 4 of them today. The truth is this last category is more of just realizing that sometimes there's some more stuff. I called it magic. You can call it whatever you want. Basically, there's a little bit more to it than just these three problems, these 3 categories. Sometimes you need a little more. A little more of what? Well, not really magic, right? You just need a little bit more math. All right, so if we want to be a little bit magical with cosine of x equals 1 plus sine, we just need some more options. Now, I'm actually going to show you an option that doesn't work, but the reason I'm showing it to you is because it does work in some cases, and it's good thinking. So, dividing everything. Now, if I decide to divide everything by maybe a certain trig function, it seems like that would be helpful, like dividing everything by cosine. Now remember, this is not going to work for this problem, but I still want you to realize that it's good thinking. And it's good algebra. You're allowed to divide everything by whatever you want. So what does this do? Well, it seems like it's doing something helpful, like cosine divided by cosine. That cancels out to be 1. Okay, 1 over cosine. Well, that turns into secant. And sine over cosine, well, I've seen that a lot. That equals tangent. You see, it turns out that we really just kind of changed the form of the equation. You might say we sort of put lipstick on the pig, but it's still a pig. But pigs are okay, and there's nothing wrong with dividing. It's just that I still have 2 trig functions. And of course, I don't want 2 trig functions. I want 1 trig function. So we need some more magic. Now, the trick is squaring both sides. And this is going to be correct, so I would suggest that you write it down. So, squaring both sides. Take a look at what happens. Now, you get cosine squared. That's pretty easy. But please, please, please square 1 plus sine like a FOIL problem. Please think of that as 1 plus sine times 1 plus sine. Now, some of you will do that in your head. Some of you will write it out. It's fine, no matter what you do, as long as you correctly square 1 plus sine to get 1, and then to get sine and another sine to be 2 sine, and finally to get sine squared. So we square both sides. Now, squaring both sides is a little trick, and it's a little trick that comes in handy when you need to change something like cosine squared to another trig function, to a sine trig function, like a sine squared, like a 1 minus sine squared. And this is really the reason that we squared both sides, because now everything is the same trig function. Everything is sines. Of course, there are some other things on the board, but cosine squared was the only way that I was going to be able to change this function to be all sines. All right, let's clean it up. Let's kind of gather like terms. I hope you see that these ones, I could subtract them from both sides, and it turns out that they actually cancel. And how about this sine squared? I could add that to both sides. I could add those like terms. Okay, so we kind of organize it, clean it up. We end up with 0 equals 2 sine plus 2 sine squared. Now this problem is kind of leading itself towards factoring because I see I have it equal to 0, and I also have repeated functions. I have sine repeating itself. This 2, though, it's kind of just in the way, so there's no reason I can't divide it away. We're just going to divide everything by 2. Just kind of gets rid of that extra number. Makes it a little easier to see the factoring. Do you see it? You're going to factor out a sine. That leaves you with 1 plus sine. And now we're at a spot that we were at just a few examples ago where we can solve each of these equal to 0. And of course, when you solve them equal to 0, you have to take the inverse sine as your final step. So take the inverse sine of 0. You actually still get 0. This one, you want to take the inverse of negative 1, because you're going to subtract this 1 to the other side. So the inverse of negative 1 is negative 90. And that's the magic. Squaring both sides.